We'll now continue with Z transform 5.2 pairs and properties. Here we'll define or we'll study some Z transform pairs, their properties, and we'll derive some of these pairs and properties. This is a detail. We'll begin with the table of Z transform. Typically, when we are given a table of Z transform, this is given. First, on the left hand side, we are given the sequence. So here we are given 10 different xn. So this is the impulse response, the step response, the real exponential, decaying or growing, and we are interested typically in the causal signal. Here un represents the step function, or here it is the anti-causal signal. So this is a Z transform for both causal and anti-causal signal. In the second column, you will then see the Z transform of the particular xn. Z transform of the impulse is 1. And on the last column, we will show you the region of convergence. The region of convergence for the impulse is all of Z. Region of convergence for un is only for the absolute value of Z greater than 1. So remember, whenever we have a causal signal, the convergence is always external to the largest pole. Well, here, when we have a anti-causal signal, the convergence is from the pole nearest to the origin and string it to the origin. So from the region of convergence, we would know who is the anti-causal signal. So anyone that have this kind of characteristics less than A are anti-causal signal. The anti-causal signal here, and therefore correspondingly their region of convergence will be less than the pole location nearest to the origin. While for the causal signal, let's draw another color for causal signal. Then the convergence is all greater than some value. The other thing to notice is that the Z transform sometimes is expressed as 1 over 1 minus Z minus 1. This is negative power of Z. Let's multiply both top and bottom by Z. Is Z over Z minus 1. So this multiplied by Z, it is Z over Z minus A. So some books prefer to represent the Z transform in the positive power. So this is on the right hand side. It's exactly the same. And then now you see the different representation of x of Z. And again, you must include the region of convergence in the last column. So we don't expect you to memorize all the Z transform table. You are given you'll be given a table if necessary, or you'll be asked to derive it if that is the exam question, or quiz question, or lab question. What we expect you to be able to do is, given the Z transform entries, you'll be able to manipulate them. Typically, I prefer the positive power of Z, and so I list now more entries for you where we have cosine as well as multiplying by some exponential, decaying or growing depending on gamma. With the Z transform pairs, we now go to the Z transform properties. Here we just overview what are the properties, and we will do some proof later on. Z transform is a linear operation. That means when we have x1n plus x2n, the Z transform of this can be realized individually by Z transform of x1n plus Z transform of x2n. The scalar multiplication of alpha times xn, the alpha can bring out. And now we have delay, time shifting, right time shifting, and then we have, sometimes we prefer to do z minus m x of z. Now, the following entries deals with these issues where the entries of x exist originally on the left hand side, which is the anti-causal part, and because we are doing right shifting, then what happened is that these entries will be moved to the right hand side. So we have to take care of these entries later on. So you must be very careful whether we are including this, that means we are zeroing out the original entries on the left hand side, or we are shifting the entries from the left hand side to the right hand side, and hence we must take care of those entries on the left originally. Similarly, for left shifting, when we are doing plus, so we are shifting the entire sequence to the left hand side, we must get rid of all the signals in the Z representation that will pop out, but there is no more because it has been shifted left. You can do some practice by yourself and you will realize these equations meaning and interpretation. Alright, the rest of the properties are, in particular, we are most interested in the final value and the initial value, the time convolution, so this must be used. This we are not so interested in, and this is a summary of the Z-transform properties. In the next few slides, we will go through how we'll use the Z-transform pairs or derive the Z-transform pair as well as some of the properties. Thank you.